Hi students, welcome to the video. Today we are going to discuss about graph traversal methods. We have two traversal methods here. First one is breadth first search traversal. Second one is depth first search traversal. Two traversal methods are there. So first of all, we all know that traversal is a process of visiting each and every node in the data structure graph. Last classes we discussed about the traversals like in-order traversal for tree, in-order, pre-order and post-order traversals for a binary tree. Likewise, here we have a traversal method like breadth first search traversal and depth first search traversal. In a binary tree or a binary search tree, the traversal can be performed only with the help of a root node. A root node is there. From the root node we can go up to each and every node, and then we will finalize the traversal list of nodes in the list of elements that we traversed. So for all the operations, for in the case of insertion, deletion, display, whatever it may be, you have to depend on that particular node named as root node. Then only we can perform the traversal or insertion or deletion or search or whatever it may be. But in this case of so what is the disadvantage of that? If we are depending on a route, then the traversal time or the visiting time or the searching time may get increased, because each and every time for a traversal we have to go to the root node, then from the root node then we have to go for that particular node likewise. So it is time consuming. In the case of a graph is a nonlinear data structure. Of course, it is data are arranged in a scattered order, not in a sequential order. So breadth first search traversal is one of the traversal method that and another traversal method is depth first search traversal. You can start from any node for the traversal. That is a concept here for traversal. So first we are going to discuss about breadth first search traversal. Okay. Here the data structure used for this traversal. So graph is a data structure, and for traversal we are depending on another data structure named as queue in the case of BFS. So queue is needed, queue array is needed for performing this traversal operation. So in this case, every node will have a two stage. One is visited stage, another one is unvisited stage. That means visited stage in the sense, once we completed the process on a particular node is said to be visited state, and the process the pending the node with which whose process is pending is said to be unvisited state of a particular node. So two stages are there: visited state and unvisited state. So I am going to start from 0 for traversal. As per the rule, what we are going to do is the first node will be first stored in the queue. That is the first step. So after that, what we are going to do is we are going to delete this particular node. So I am going to delete this one. Okay, I am not going to represent the front and rear value because it's hidden. You already familiar about that. So it's a queue. So 0 is now deleted and stored in the output list. Okay, now it is stored in the output list. So 0 is added in the output list and deleted from the queue. The next step is to identify the adjacent nodes. We already discussed about the meaning of adjacent nodes in the last videos. Adjacent nodes are the elements which are directly connected to that particular node or from that particular node. So here 0, in the case of a 0, 1 and 3 are the adjacent nodes. Okay. For in the case of a 3, 0, 1, 2, 4 are adjacent nodes that we already discussed. Okay. In this case, we first step is we store the value in a queue, and in the second stage, that means we visited. The meaning is we visited and we added that value in the output array. Next step is to identify the adjacent nodes of 0. Adjacent nodes of 0 are 1 and 3. The next step is to add this value in the queue array. 1 and 3 is added. So I chose 1, then 3. You can choose 3 and then 1. It's not a problem. That is an important thing. It's up to you that which one you are selecting first is very important. So based on this, the output may vary. Listen, here I am choosing 1 as a first node, first adjacent node, 3 as the second adjacent node. So what will happen automatically if the next step is I am going to delete this particular node for processing. So this is deleted and added in the output array. So the output is 0 and 1. Clear? If I am choosing the reverse order, the second order, that means first I am choosing 3, then I am choosing 1. Okay. The next process for deletion is 3 is selected for is because in the first order 3 is the option that we have for deletion. So 3 is in the visited stage. Okay. So output may vary. So the value that is representing the output is not so important. The step or the procedure that we are following for a traversal is very important. Okay. So you have multiple answers for a traversal in the case of a graph. In the case of a graph alone, you will have multiple answers. But what we are taking care is we are going to follow the exact procedure for traversing this graph. Okay. So now I am choosing first 1 and second adjacent node as 3. So I chose so 1 is deleted and added in the output list. Okay. Next step is to identify the adjacent nodes of 1. What are the adjacent nodes of 1? Adjacent nodes of 1 are 0, 3, then 2, then 6 and 5. These are the adjacent nodes. 0, then 3, then 2, then 6 and 5. Here also you can choose in any order. Okay. But for my convenience, what I am doing is I am going to choose in the sorted order, that is 0, then 2, then 0 already added, already visited, so we can't add that, or we can consider this one. Then 3 is already added, it is in the unvisited stage, it's for processing. Okay, so we can omit these two adjacent nodes, 0 and 3. The next adjacent node is 2, so you can add 2 here. 2 is unvisited node. Then the next element is next adjacent element is 6 and 5. So you can choose either 5 or 6. It's up to you. I am choosing 6, then 5. Okay. So that it's up to you. You can choose in any order. It's not a matter here. It's not so important here. Okay. So in the case of 1, we have adjacent nodes are 0, 3, 2, 6 and 5. And 0 already visited, 3 is under processing. That means next element for processing is 3. So the visited status of 0 is 1 and 3 is unvisited, but it's under processing. So we are not considering these two adjacent nodes. We are considering only 2, 6 and 5. Okay. Next step is to delete the next element, that is 3. 3 I deleted and 3 is added in the output. And next step is to identify the adjacent nodes of 3. Adjacent nodes of 3 are 0, 1, 2 and 4. And 0, 1, 2 are already visited and in the processing stage. That is 0 and 1 are already visited nodes and 2 is under processing. So what you can do is you can add 4 alone, because 4 is the only element that is there for unvisited and not in the processing stage. So now I added 4 in the queue. Okay. No more elements, I think. Next element for processing is 2. I am choosing 2 and I deleted 2 also. Okay. 2 also deleted. So the visited nodes are 0 is a visited node. Okay. 1 is a visited node. You can mark it like this. 3 also a visited node. Then 2 also visited node. Okay. Next element for deletion is 6. So I am deleting 6 here and added in the output list. Okay. Adjacent nodes of 6. Adjacent nodes of 6 are 4 and 1. 1 already visited and 4 is in the waiting stage. So nothing is there to add in the queue. So that is also visited. That's also added. 4 is also added. Next element for deletion is 5. So 5 is deleted and added in the output list. Okay, then 5 is now visited. Okay, adjacent nodes of 5. 1 and 2 are the adjacent nodes. 1 is visited node, 2 is also a visited node. So nothing is there to add. Next element for the deletion is 4. 4 is deleted. And adjacent nodes of, so 6 also visited. I forgot to mark. Okay, 4 is now visited. Okay, no more adjacent nodes of 4 are 3, 2 and 6 all are visited. So the process is completed. So the graph traversal output for this particular graph in BFS binary, breadth first search traversal is 0, 1, 3, 2, 6 and 6, 5 and 4. This is one answer. I can give you another answer because I told you this is a graph traversal, so you will get multiple answers based on the way that you are choosing the node for a traversal. Okay, so now we are traversing in another order so that you will get a different answer. But here the important thing is we have that rule or a procedure for traversal that you have to maintain, otherwise you will not get the mark in the university examination. Okay, the first step is to, I am starting from 0 again. First step is to add 0 here. Okay, after that the second step, I deleted 0 and added in the output list. Okay, that is the first step. Okay, 0 added in the output list. Okay, next step is to identify the adjacent nodes of 0. Adjacent nodes of 0 are 3 and 1. Okay, I am choosing 3, then I am choosing 1. Okay, these are the adjacent nodes. Next option for deletion, next element for deletion is 3 in the case of a queue. So I deleted 3 and added in the output list. Okay, 1 is there. And adjacent nodes, next step is to identify the adjacent nodes of 3, 0, 1, 2 and 4. 0 is in the visited stage and 1 is also in the queue. So you can add 2 and 4. So I am adding 2, then I am adding 4 in the queue. So adjacent nodes of 3 are 0, 1, 2 and 4. 0 is in the visited node, 0 is a visited node, 1 is under processing. Then 2 more elements are there, 2 and 4. So these 2 elements are added in the queue. Next step is to delete 1 and added in the list. So adjacent nodes of 1. Adjacent nodes of 1 has to be identified. So here adjacent nodes are 0, 3, 2, 6 and 5 are the adjacent nodes. So 0 is a visited node, 3 is also a visited node, 2 is under processing, then 6 and 5 are still not added. Okay, so I am adding 6, then I am adding 5. Okay, so next step is to delete the element. So the element for deletion is 2, so I am adding 2 here. The adjacent nodes of 2. Adjacent nodes of 2 are 1, 3, 4 and 5. 1, 3, 4 and 5 are the adjacent nodes. So 1 is a visited node, 3 is also a visited node, 4 is under processing, 5 is under processing. So these are the, and the adjacent nodes okay, these are the adjacent nodes and all are in the processing stage and also in the visited stage. So I can delete the next element, that is 4. I am adding 4 here. Adjacent nodes of 4, 3, 2 and 6 are the adjacent nodes. 3 and 2 are already visited, 6 is under processing. Okay, next step is to delete 6 and add in the output array 6. Adjacent nodes of 6 are 4 and 1. 1 already visited, 4 also visited. Okay, so that's also completed. Then 5, I am deleting 5 and add in the output list. and adjacent nodes of 5, 1 and 2. So 1 already visited, 2 already visited, so almost all the elements, not almost, all the elements are visited. So this is the output list in the case of a breadth first search traversal. Hope you clear about this. So here what I am trying to say is here the procedure is very important, not the output value, because it may vary. So I chose 3 and 1 first example. I chose 1 and then 3, so you got a different output. Now I chose 3 and 1, so you got a different output. Likewise, you can choose instead of 2, you can add 4 first, then 2, so automatically the value may differ. But here the important thing is that traversal method is having its own procedure. You have to follow that procedure, then only you will get the clear output. Okay, thank you.